Hello everyone, I'm Masumi Marashige from Keio University in Japan, and our research title is the evaluation of clustering-based parcellation in the visual cortex. So first of all, the cerebral cortex can be subdivided into multiple areas, and the subdivided map is called the brain parcellation map. In systems neuroscience, the accurate parcellation map is very important to suggest accurate findings. However, there's still a lingering question of which parcellation map provides the best job of subdividing functional brain activity. As shown in the lower figure, there are still so many parcellation maps right now, and we cannot decide which parcellation map we should use. So our research objectives is to propose a novel evaluation protocol that can compare how well the parcellation cluster identifies the region of fMRI data. Firstly, we generated a parcellation map using HAC, which stands for hierarchical agglomerative clustering. Then we extracted the low-dimensional latent space feature using principal component analysis. So next, we compared the silhouette coefficient value between anatomical parcellation, HAC parcellation, and random label parcellation. This silhouette coefficient value represents how well the clusters were separated. And finally, we tested the difference of the silhouette coefficient values statistically. In our analysis, we used the K dataset, and this dataset is an fMRI dataset, while each subject viewed a collection of natural images, like in the figure in the left side. Inside this fMRI data, the features of the fMRI responses, are standardized and have anatomical labels in each voxels. We generated the parcellation map using HAC and randomized the label, and finally prepared these three parcellation maps to compare. After reducing the dimensionality by PCA, we calculated the silhouette coefficient value, representing how well the clusters were separated. And the upper figure shows the clustering visualization result. And each plot shows the coordinates in the latent space of each colored cluster. The lower figure shows the silhouette coefficient value, which corresponds to the x-axis. And when the x-axis is high and reaches to the right, it means that the cluster is well separated. So the results quantitatively suggest that the HAC parcellation has clustered the functional flow very well. We then statistically tested the silhouette coefficient value. First, we had tested its normality to decide the statistical methods. The Shaper-Wilk test was significant, which means that there is no normality in the score distribution. Therefore, we decided to have a statistical test on the Kruskal-Wallis test and the Mann-Whitney test for the post hoc analysis. Both analyses were significant, and the results showed that HAC clusters separated better than the other groups. Also, it was surprising that the anatomical parcellation was worse in separating the clusters than the random labeled parcellation map. Next, we would like to interpret these results, and in previous research said that the structural parcellation might fail to fully reflect the brain's intrinsic organization and capture the functional variability inherent in individual brains. Therefore, our results are reasonable that parcellation maps generated by fMRI data reflect the functional flow in visual cortex layers compared to the anatomical parcellation map. In conclusion, our research advanced methodologically by proposing the novel evaluation pipeline, as shown in the right-hand side's flow. Also, for a scientific advance, we illustrated how HAC could improve the parcellation maps and also suggested the importance of parcellation selection in future fMRI research. Thank you very much for listening.